In the previous examples, I solved both of these equations before, but I solved them in degrees. And this time I'm going to solve them in radians. Also, in the previous examples, we solved them with the big picture. We looked at the graphical connection to solutions. And so there was a little bit of graphical clue to help us. But this time I'm going to solve them purely with an algebraic approach. And I do still need a few clues to get me started. So I'm thinking the clues are for people who are visual. I happen to be visual. That helps me to solve this. And when I'm looking at sine theta equaling 2/5, I notice that 2/5 is positive. And so I'm thinking about answers for theta. Okay, all A smart trig class. And these are my quadrants for theta. Now sometimes theta will be positive. Okay, here's a theta. And it will be a positive theta because it's in quadrant 1 and all the trig functions will have positive ratios. So I have an answer in quadrant 1. Now sine is also positive in quadrant 2. So I have another theta. So I've actually got two solutions. Theta is going to be an element of quadrant 1 or quadrant 2 because sine will be positive twice. Positive in the first quadrant and positive in the second quadrant. So I actually am looking for two solutions. Now, our strategy is going to be to concentrate always on quadrant 1, even if the answer isn't there, because that's always the reference angle. And if we have the reference angle, we can find them all no matter what. So the trig functions get a little bit weirder when we do their inverses on sine inverse or cosine inverse or tan inverse because they have the restrictions on those quadrants. But all three of the inverse trig functions share quadrant 1 consistently. And so this is going to be our backbone to get all of our solutions. So here's the strategy. When we solve for theta, we're going to use the inverse trig function. And all the time, we're going to force it to be positive. Now, I'm putting a green plus here. I'm changing the colors. Now, it's kind of a moot point because it's already positive. So there's no forcing here. But on number 2, that will be a concern. But it's already positive. And when I solve this, it's going to tell me quadrant 1, which is the reference angle. And I have a solution in quadrant 1, so I need that solution anyway. So this is going to tell me what my quadrant 1 solution is, my very first answer. All I have to do now is put that in the calculator. Now, unlike the last problem, we were in degrees. And we solved and got degree answers. But this time, I do not want to be in degrees. I want to be in radians, so I'm going to set myself in radian mode. And then I'm going to clear or quit this screen. And I'm going to type it in. Sine inverse of 2/5, hit enter. And this time, I forget already what our degrees were before a few minutes ago when we solved it. I think it was 33 degrees, something like that. But we're getting a radian answer. Theta equals 0.4115. Now this is a decimal round off of fractions of pi. Now pi is an irrational, it is an irrational decimal that never repeats and never stops. So this is just a round off. Whenever we're doing radians, we get these decimals and they're going to be round off answers. So I might as well put approximately there. Okay, but that's only one of the answers. That's quadrant 1. I'm done with that one. Next, I need to find quadrant 2. Well, I have the reference angle. Quadrant 1 is my reference angle. Now in quadrant 2, this represents my reference angle. So if I subtract 180 minus the reference angle, I'm going to get the quadrant 2 solution. So I said 180, sorry. It's pi minus the reference angle. Now, I'm working in radians, so I'm working with these decimals of pi, and so I'm going to need my calculator to do that for me again. So I'm going to come in here and put in pi minus, here's the reference angle, so I'm going to go up there and grab it, hit enter, and then enter the subtraction. And the second quadrant angle is 2.7301. We'll go out to 4 decimals here. 2.7301. So here are my 2 solutions. But this time, it's the same 2 solutions we got a minute ago in degrees. It's just this time we're finding the 2 answers in radians. The trick is always going to be, or the consistent way, there's many ways to solve these, but some people get confused with these restrictions. Because sine is restricted to 1 and 4, cosine is restricted to 1 and 2, and tangent's restricted to quadrants 1 and 4, and it gets a little bit mixed up there. But if you focus on quadrant 1, that will be your building block to find any other answer you need. So let's repeat that and solve this other one here. Okay, now, where are my solutions? Well, we're thinking a smart trig class. Cosine is positive in these two, but I don't need positive. I need it to equal a negative ratio. So cosine is negative in theta is got to be in quadrant 2 or quadrant 3. So whatever my angle is, I have one coming over here, and I have another one coming over here. I have 2 answers I got to find. The second quadrant, cosine is negative. Third quadrant, cosine is negative. So I'm looking for 2 solutions between 0 and 2 pi, and they're going to wind up in the second quadrant and the third quadrant. Okay, now here's where the quadrant 1 gives us the reference angle is going to be very important, because the inverse cosine does not work for quadrant 3 or 4. It will not tell me this one. It will not tell me anytime I have a quadrant 4 answer, which I don't in this case, but the inverse cosine doesn't work in these 2 quadrants. For sine, it doesn't work in these 2 quadrants, only 1 and 4. So it gets kind of mixed up. Now here's how to play it safe. Find the reference angle. So we're always going to find the reference angle. Find the reference angle, and the way you do that is do the inverse cosine, but the reference angle is equal to quadrant 1, so we have to force the ratio to be a positive ratio. So we're tricking the problem here. We're hacking this thing, and we force it to be positive number, not a negative number. And when it's a positive number, all inverse cosines will automatically give us quadrant 1 solutions. And quadrant 1 solutions are the reference angles. Okay, so I'm going to get the reference angle immediately here. And so let's do some calculator work here. Cosine inverse of positive. I'm not putting that negative in there. 5 divided by 6. And I get a reference angle. This is radians now, so it's a crazy looking decimal, but the reference angle is 0.5 857. That's my reference angle. It's quadrant 1. Because this was positive, cosine inverse of a positive is going to give me quadrant 1. Now, that's not my true solution. My true solutions are in quadrant 2 and quadrant 3. But because I know the reference angle, I can solve for these other answers. So let's go over here and solve for quadrant 2. Now, if I want the solution for quadrant 2, theta this would be like the reference angle right here. And so the reference angle plus the true angle is up to 180. So I can use the 180. Now in this case though, because I'm in radians, I'm not going to call it 180. I'm going to call it pi minus the reference angle. And that is just purely a calculator problem. I have the reference angle, I have pi, I'm going to do the subtraction. So pi minus, I'm going to come up here and grab the reference angle, minus that, and then enter the subtraction. And I got my quadrant 2 solution. It's approximate 2.5560. So I'm keeping them to 4 decimals here. All right, I'm almost done. I got one more of these. So now I want to do quadrant 3. Okay, well, quadrant 3 is down here. And this would be like the reference angle. So I have the reference angle. And if I take 180 plus this red part, I'm going to get the true angle in quadrant 3. So this time, I'm going to do pi plus the reference angle. And it's simple. I got the reference angle. It's in the calculator. It's still up here. And so I'm going to, there's a couple ways I could do this, but I'm going to go pi plus, I'm coming up here to grab the reference angle. Now, if you have a really old operating system, you may not be able to back your way up and enter it in like that. So you might have to manually type in this number. But with the newer operating systems, you can go back into history, call something from history, put it on the command line, hit enter, and now I got my theta. It's 3.7273. There is my 2 solutions in radians. So it's just a repeat strategy. You should compare the degree solution we did with the radian solution we did. And you can kind of see it's just repeating the strategy. The only difference is the radian answers are more complicated decimals. Okay, let's do 2 more solutions. And these last 2 are different in the sense that we are working with stuff that is not sine and not cosine. Now, if you look at your calculator, beware. Beware. I have a sine inverse, a cosine inverse, a tan inverse. Can I reverse cotangent with the calculator? All right, here comes a curveball. This is a trick question. Don't fall for it. Don't fall for this. Okay, if I'm going to do cotangent inverse, well, wait. Is that just tangent to the -1? Can I use the tan inverse to solve cotangent equations? And the answer to this is no. Tan inverse reverses tan. Some people will see this -1 in their brain. They get switched over and they think exponents. As an exponent, yes, with the exponent and a variable, it is a reciprocal. But this is not an exponent. This is an inverse function. And inverse functions reverse the original function. So this has nothing to do with an exponent. It has nothing to do with the reciprocal. It is true that the reciprocal of tangent is cotangent and vice versa. But this is exponents, not inverse functions. Okay, so don't confuse these two ideas together. This idea of reciprocal function, reciprocal fractions is different than an inverse function. I know that's confusing. That's real easy to switch over. But when we do the inverse function, this is not an exponent. It's not a reciprocal. We're not doing that. Okay, so that is a dilemma. Because if we're going to solve this for theta, the only thing that would undo cotangent is cotangent inverse. That is what reverses cotangent. Okay, but this is problematic for us. Unfortunately, if you look on your calculator, you do not have a cotangent inverse. Unless, of course, you paid a lot more money and got a much more powerful calculator. But I'm not going to go down that road. All we have is sine inverse, cosine inverse, tan inverse. So technically right now with this calculator, I cannot do that problem. Shoot. Here's where we have to be smarter than our calculators, and we have to have some ingenuity and creativity. And this is why I ask you to memorize your identities. Because if you know identities, you can turn this hard problem into an easier problem. And that's what we have to do. We do wind up needing these identities. So I can't solve this problem because it's not a tan inverse. I have to change this problem into something I can solve. But I can use identities here. So 1 over tan theta equals cotangent. So I could say 1 over tangent equals negative 2.345. Now I still can't solve this because I don't have tangent by itself. If I did have tangent by itself, then I could do tan inverse, but this is not tangent by itself. So I'm going to take the reciprocal of both sides. Now once you practice this and get good at it, you can skip this step and you can go right to this step. Tan theta equals 1 over negative 2.345. Cotangent was not solvable in my calculator, but this is. I can solve a tangent equation because I have an inverse tangent function. Alrighty, so let's do this one in degrees. From 0 to 360. And so I don't forget, I'm going to do this one in radians from 0 to 2 pi. Okay, so we're looking for degree solutions. All right, just to kind of visualize, where is tangent negative? A smart trig class. Tangent is negative here and here. So this equation, whatever it is going to answer in quadrant 2 or quadrant 4. I need these two quadrants. Okay, now I'm going to do the same strategy because tan inverse will never answer quadrant 2. It will never answer quadrant 3. It will only answer 1 and 4. But even if it tries to answer 4, it won't be between 0 and 360. It's going to be a negative angle, and it's just kind of all messed up. So the way to get around this thing, it's all messed up, is go after the reference angle. So first, find the reference angle. That's quadrant 1. And it's really easy little trick. We can trick the problem to find it. So I'm going to do the inverse function, but I'm focusing on the reference angle. And here is how I trick the problem. Hopefully you remember, since we've done a couple of these now. How do I force the reference angle solution? We force the ratio to be positive. And we're going to have 1 divided by 2.345. Now we're going to have to put that inside the calculator, inside the tangent inverse. I forgot to put the inverse symbol here. So the reference angle is the tan inverse of this fraction. The rest is easy now. The rest is just calculator work. So let's get our degrees. Make sure we're in degree mode. This will be important from now on. You have to always be thinking about this. So are we doing a degree problem or a radian problem? So check your mode. We're doing degrees. I'm going to do tan inverse of 1. And notice this fraction is inside the tan inverse. So I'm going to do 1 divided by 2.345, close the parenthesis, and I got 23.09. Let's just call that 23 degrees. So that is my reference angle. Now that is not the true solutions. Maybe I should have kept it all green to keep the color coding. That's only the reference angle. I still have to find quadrant 2 and quadrant 3 because I need the ratio to be negative. But because I know the reference angle, I can go over here in quadrant 2, no problem. So my real solution is in quadrant 2. Theta will be 180 minus the reference angle, which is going to equal 157 degrees. So I got one solution pretty quick. Oops, the other answer is in quadrant 4. So I'm coming over here to quadrant 4. Okay, well, if theta goes all the way over here to quadrant 4, this is like the reference angle. So it would be like 360 minus that little reference angle is going to give me the blue theta there. So in this, for quadrant 4, we have to go 360 minus the reference angle. So I have the reference angle up here, 360 minus 23. That's going to be 337 degrees. There are both solutions. And these are things we can check. We can plug these numbers into this equation and see that it comes out. Why don't we do one of those? Let's check real quick. Now I can't type tangent. I don't have tangent in my buttons, but I do have 1 over tangent. Sorry, I cannot type cotangent because I don't have a cotangent button. But I can type 1 over tan, 1 divided by tangent, and I want to check 337. 337, close the parenthesis, hit enter, and what does it come out to be? Negative 2.3558, which is 35. Okay, now why isn't it exactly the same? It's because I have some round off here with this number. It was 23.095. What if I make it more exact? Oh, I'm not going to. So we're close. We're close because we had some round off. And so this is confirmation enough that we're close enough to this to know this is a round off. It is approximate, but it is a good solution. Let's do one more. And this time we're going to do a cosecant. And we have a similar problem. We have no cosecant button. Since there's only have sine, cosine, and tangent, we can't solve this in the calculator. We do not have an inverse cosecant. This only thing that would solve this theoretically for theta is the cosecant inverse of negative 8.536. And again, this inverse is not a reciprocal. It doesn't connect me to the sine button. Cannot use the sine button because cosecant, that's not an reciprocal, that's an inverse function. And we don't have this button. We can't really do this in our calculator. So we've got to change this hard equation into something easier. We're fortunate that we have identities. Cosecant is equal 1 over sine of theta. We are using this reciprocal identity, but this is not an inverse. This is a reciprocal. Now, once you get the hang of this, you could skip this step, but I suggest you don't at first. I cannot solve for the inverse sine unless sine is by itself. So I have to get sine by itself, and I'm going to do that by taking the reciprocal of both sides. So I flip this side, I'm going to flip that side. This is solvable now because I have an inverse sine. But before I do, I want to figure out my solutions. It's got a negative ratio. We're thinking a smart trig class. Okay, sine is only negative in these two quadrants. So I'm going to have to come up with a quadrant 3 answer and a quadrant 4 answer. But just to avoid any confusion, so I can get both, I'm going to get the reference angle. So here's where I'm going to trick the problem. Force the reference angle, do the inverse sine, but we're going to do the inverse sine with a positive ratio. I'm forcing it to be positive. That forces me into quadrant 1 because they're all positive in quadrant 1. All of them, sine, cosine, tangent. This is the one thing that works consistently with all our inverse trig functions is quadrant 1 solutions. And so this way, I don't have to worry about all those quadrant restrictions. So now it's calculator time. Okay, so I got to be in radian mode this time. So I'm doing my radians. I'm in radian mode. I'm going to do the sine inverse of positive 1 divided by 8.536. Now, because we're getting, this is a ratio, the output is a radian. It's a radian decimal of some fraction of pi. And so pi values are irrational, so the decimals never really come out nice. So we're going to have approximately 0.1174. That is my radian answer for the reference angle. But I don't want ultimately the reference angle. I want the quadrant 3 solution and the quadrant 4 solution. So let's find quadrant 3 first. If I were over in quadrant 3 and getting that solution down there in quadrant 3, I could take 180, and this little piece here would be like my reference angle. So if I add the reference angle to the 180, I will get the third quadrant answer. But it's not 180 because we're in radians. So instead of 180, it's pi plus the reference angle. So let's do pi plus this number, and I get theta approximately 3.2590. There's my first solution. And let's do one more. I need quadrant 4. So this time the angle is way over here in quadrant 4. And this little piece here would correlate to the reference angle. So it's like all the way around the circle, 360 or 2 pi. And so if I take 2 pi and subtract off this little green segment, I will be getting the fourth quadrant angle. So very similar to this problem. It was 360 minus the reference angle. Well, in quadrant 4 this time, the real angle is 2 pi minus the reference angle. So we're just switching 360 to 2 pi. And I'm going to come in here and do 2 pi minus, I'm coming up here, here's my reference angle, I'm highlighting. And if you can't do that in your older operating system, just write down this this round off here. Hit enter, and so I got approximately 6.1658. There is my second solution. Okay, real quick. Let's say I want to check this. And I can check this with an intersection strategy. I'm going to graph this and see where it intersects. So I have to be in radian mode. I am. I have to be y equals. So I cannot type cosecant in, but I can type 1 over sine. So I'm going to type 1 over sine of x, close that. And so that's like my cosecant side of the equation. My other side of the equation is negative 8.536. I'm going to put that on the other side of another graph, negative 8.536. And I want to see where these two intersect. Now I am only interested in 0 to 2 pi. So when I do my window, I'm going to go 0 to 2 pi. And I'm going to count the scale. Let's count it by pi divided by 4, pi fourths. Now, one equation is negative 8. So my y equation is going to be horizontal at negative 8. So I need the y's to go way down. And I might as well just leave negative 10 to 10 and see what this graph looks like. So we're going to graph. And here's the cosecant. You may recognize the cosecant. It has those two humps. And there is the negative 8. And there are two solutions. Okay, so this is confirming the fact that I had two solutions. But I want to be more specific and confirm exactly these values and make sure I got them right. And I can do that with the intersections. So I'm going to go to the cal command here, above trace, second trace. And I'm going to go to the intersect. And it's going to ask me a couple questions. Which one is the first curve? Is this one the first curve? I'm going to hit enter to say yes. Second question says, okay, which one's the second curve? Is it this one? I'm going to say yes. And then it needs a guess. Okay, so I'm going to move close to the intersection. So I've got my cursor close to the intersection. I'm going to hit enter. And the y number equals negative 8.536 when the input is 3.259. 3.259. Bingo. I've got confirmation that my algebra is correct because the graphing is matching my algebra. If we needed to convince ourselves more, we could intersect the other one as well. So it's got to ask the first curve again and the second curve again. And then it needs the guess. So this time I'm going to move my guess way over close to the other solution. And I'm going to hit enter. And I got 6.1657, 6.1658. This is confirmation that my algebra is correct. All right. Hopefully those solving equations are helpful for you. Study this really hard because it'll be a big deal in chapter 9. All right. Good luck with all this, you guys.